So today I want to talk about the Spearman rank correlation, which is the or a non-parametric equivalent for the linear correlation coefficient. So here we have another fictitious data set, and we have two sets of variables really. So we have age and we have systolic blood pressure. So that's SPP, systolic blood pressure. And both are quantitative variables. However, these variables could be transformed into categories and into actually ordinal variables. So next to age is age group, and you have young adult, middle age, and senior, which could be ranked because you have young, then middle, then senior. And then we have next to systolic blood pressure, we have systolic blood pressure categories. So we have normal blood pressure, elevated, and high blood pressure as the categories, and those are also ranked. So we want to use this Spearman rank correlation. And before we get into it, let's discuss when is this test useful, when is it relevant. So the Spearman rank correlation is ideal when the relationship is monotonic but not linear. As in, you could see that as one variable is increasing, the next one is increasing, or as one is increasing, the other is decreasing. So you could see that relationship. However, when you do a scatter plot, you realize it's not a straight line that's generally seen. Probably you see a curve or something like that, but overall it's going into one direction. So it's monotonic but not linear. Then you can't do a Pearson correlation coefficient. So you'd have to do now a Spearman rank correlation. Or if you check for normality or bivariate normal distribution, you realize you're not getting that. You're not getting that so much, especially normality between the two variables. You're not seeing a normal distribution, or you cannot, assume it to be normally distributed. Or if there are significant outliers that are not errors, and you really can't remove them all from the data set to calculate a correlation. Or if you check for homoscedasticity and you look and you realize there's no homoscedasticity. Or probably you might want to know the correlation when you have an ordinal variable and a continuous variable, or you probably have two ordinal variables. Then the Spearman rank could be used, because the linear correlation coefficient or the Pearson's correlation coefficient cannot be used under these circumstances. So what are the requirements? So when you're testing association between the two variables, and you're looking to say a null hypothesis is that rho or the correlation is equal to 0, because 0 means no correlation. And the alternate hypothesis would be that the correlation is not equal to 0, meaning there is a correlation. And the requirements are very simple. So yes, you have to have paired sample data, and if you're using it to make inference or an inference about a population, then you need to be taken from a simple random sample. And the next requirement is that the data has to be able to be in ranks or can be converted to ranks, meaning that basically we're seeing it could be a quantitative variable which is in order, or like an ordinal variable which the values are also in order. So now let's look at an example from our data set, or let's look at different examples from our data set. So firstly, what we need to do is to examine the scatter plot, because the scatter plot will give us an idea of the appropriateness of the data set for use, whether it be the linear correlation or whether it be the Spearman. So we'll go to graph, let's do a scatter plot, and we want to put age on our x-axis, and let's put systolic blood pressure on our y-axis if we're thinking that systolic blood pressure is dependent on age, and we click OK. So when we look now, we get a graph like this. So we see here that after a certain age, the blood pressure values kind of remain the same, but it's still going in one direction. If you look here, you see a line. It's not really a straight line. It looks straight, but we're seeing somewhat of a curve, or we're seeing a few outliers and that kind of thing. So this data would more than likely not be so appropriate for the linear correlation. So we could ideally use a Spearman. So how do you find this Spearman correlation? Well, to do this now, pay attention. You go to Analyze, you go to Descriptives. So you're not going to Non-Parametric, okay? No, not Non-Parametric. You're going to Descriptives. And then you're going to Cross Tabs. Yes, Cross Tabs. You wouldn't expect to find it there, but this is how you would find the statistic test that we're looking for. So now let's put in the row age in years, and we'll put systolic blood pressure in the column section. So I'll say in format, we're leaving everything as is. When we go to statistics, however, we're not really doing a chi-square, so we could uncheck that. However, you're coming down to this that says COR, which is the short for correlation. As you see, it comes up here, Spearman correlation and Pearson's R. So it gives you both. So you ensure you check that box and you click continue. Under cells, because we're not really looking to use any tables for analysis, we're going to uncheck everything and we're going to put here none. So we're asking it not to display any tables or cells. And you click continue and then we click OK. So when we come to our output now, here we see here it says ordinal by ordinal Spearman correlation because it's looking at ranks. So Spearman correlation, here the value is 0.96, which is a really strong positive correlation, and we see the significance level here, which is less than our alpha of 0.05, which tells us that this correlation is indeed significant, and at the population level there is a correlation that could be inferred from this sample data. And as I said as well, the output will also give you a Pearson's R, even though the data, as we'll review from this scatter plot here, is not appropriate. But when you do this technique, it gives you both, and you could compare them. As you could see, it's not really saying it's much different. Right, so as I was explaining as well, that you could, if we go back to Analyze Descriptives, Cross Tabs, say for example, we switch out systolic blood pressure for blood pressure category. So we're using a quantitative variable and an ordinal variable. That could also be done. And because everything is already in place, we're just going to click OK. And we'll come right here. And when we look, we have our next output. And here you could look, you could see that the correlation figure is actually not far from the other, the one that we previously had. Here it's 0.9, still a strong correlation. And we'll look here at the p-value. It's saying that the Spearman correlation is significant. And if we should go back to Analyze Descriptives, and we'll come to Cross Tabs, and let's switch age for age group. So we have two ordinal variables. I will click OK, and if we come right here and we scroll down, we get a Spearman R value of 0.8, which is still a strong correlation, and the significance value we see in here is still less than our alpha of 0.05, which tells that this is a significant correlation that we could use it to estimate at the population level. And here you see the different methods. You could use two ordinal variable, a quantitative variable, and an ordinal variable, or two quantitative variables when it's not appropriate to do the linear correlation coefficient. We could use the Spearman's rank, and that is how you do the Spearman rank correlation using PSPP.